Welcome to the fourth and final part in my video series on configuring 7-segment displays using I2C and MCP23008 integrated chips. In the past 3 videos, we have successfully managed to address a single chip and output digits on a 7-segment display. But what if we want to add multiple displays or multiple chips? I2C, based on its byte addressing, can address up to 8 separate MCP23008 chips, which means for this chip we could directly control 8 7-segment displays using just the 2 I2C wires. If we were to swap it out for the MCP23017 chip, which produces 16 outputs, we could double that number. The current setup we have produced connected all the address pins on the chip to the ground or negative rail, producing a 4-bit hexadecimal value of 0. The highest address we can therefore make by connecting all 3 to the positive terminal is 7. The 4-bit value of 2 is out of our control and handled by the manufacturer of the component. If you wanted to control more than 8 chips, we would need to find a different chip which used a separate range than 2. The PCF8574 and the PCF8574A chips are some such chips, which use the codes 4 and 7 respectively. When combined with their slave addressing of 0 to 7 each, provide up to another 8 or 16 chips, which can be controlled via I2C. This is our wiring diagram from the last video, except that I have shuffled the resistor and rail connectors a bit further down to make way for our secondary set of components. Note at this point I'm still driving the whole breadboard off my Raspberry Pi's 3.3 volt power pin. I probably wouldn't want to drive much more off this pin, as it tends to prefer a current draw of less than 50 mA. I could jump onto the 5 volt output from the Pi, which will give me almost up to 1 amp of current. However, in reality I'd recommend any decent sized projects you should investigate a secondary power source to run the breadboard, only connecting to it via the I2C control wires. Now for our secondary set of components. Firstly, let's add our second MCP23008 and our second FND500 7-segment display. With these in place, we're ready to connect up our wiring, keeping everything the same as before, except for the serial clock input and the serial data lines, and of course our address pin A0. The SCL and SDA pins will simply loop off the previous chip. The A0 pin will increment from 0 to 1 by going from a low voltage to a high voltage. This is done by connecting it to the vertical power rail instead of ground. We are expecting our chip to appear at the hexadecimal address of 21 based on the pin assignment we've implemented. So let's power on the Pi and run I2C detect again to confirm that this is the case. We can now send some output by addressing the second chip on its own at chip address 0x21. Let's test out our circuit by flashing the LED display on and off with these commands. Don't forget, we'll need to set all the pins on the chip as outputs first. The last thing to do is update our script to account for dual displays. We can simply do this by adding another address variable, which will enable us to duplicate sections of code very easily. As they are digits, I have named these for the 10s and the 1s columns, so that I know that the 1s are at 0x21 and the 10s are at 0x20. If I wanted more displays, I'd quite easily be able to extend this to the hundreds and thousands, but beyond that I'd probably dream up a different naming scheme, but whatever works for you. I'm going to write a code definition for the actual display output, which will accept a variable and then display it. This means that instead of duplicating the same code every time we want to display some output, we can simply send this method a request with our variable, and it'll take care of the rest as many times as we need it to. The first part is used to determine whether or not we are using both segment displays, or just one, which is a simple less than 10 check for any number 0 through 9. I'm running on the assumption here at this stage that we will only be presented with integer variables. For the 2-digit numbers, I'm converting these to a string and then slicing them by grabbing the first character and making this A, and the last character assigning this to B. These are then converted back into integers and pumped into the main command of write byte data. The last segment of code is going to perform the actual counting and request to display whatever digits we require. For this exercise, we'll make the display count from 0 to 99. So that we can actually read what's going on, I've added a small 0.2 second pause before incrementing the numbers. The line that has display open parentheses I close parentheses is the line where the method call happens, where we pass the current integer being requested to the definition that we described earlier, called display. After that's all done, I've sent the display as a command to switch off so that they don't get stuck displaying the number 99. Thanks for watching. That brings us to the end of my 4-part series on using the I2C interface from the Raspberry Pi. I do hope that you found these videos informative and that you managed to get your system up and running as expected. The code snippets that I have explained in the last 3 videos will be uploaded to GitHub and are linked in the comments below the videos. If you did enjoy these videos, please like and leave a comment, and feel free to subscribe to my channel. Thanks again.